working on a new section today. Things all put in the wrong place. Try that. Okay. Give this a little touch. Right. So what we're going to be looking at is section 3.7, which is called rates of change. And these are the three main topics. And the first one is we're going to look at velocity, how to calculate velocity and acceleration. We already know how to do that, but we'll do it in more detail. Then we'll talk about how in an object's journey as it moves, right? So you're thinking of a moving object. We're going to look at when you know if it's speeding up and slowing down, and how to calculate intervals of time where this object is speeding up or when it's slowing down. And then we'll finish with some general rates of change questions where it's not a moving object, but you still use derivatives. So let's start off with question 1. Right, that's typically what you would call the position function, but it can be f of t or g of t. But this is the position function. In this question, it's t cubed, take away 9t squared plus 24t. So if you wanted to know where this object was at any given point in time, t, you just plug the value of t in here and it would tell you. Now, position can be positive and it can be negative, which seems a bit strange, but it's allowed. So I want you to just imagine that position 0 was your house, and outside your house's front door, you could turn right or you could turn left. So if I said to you, you were in position 2, that would be here, right? If I said you were in position negative, say 3, you'd be here. So can you see you could have a positive position and you could have a negative position. If I did position as your vertical height, wouldn't 0 be sea level and then 1, 2, 3 feet above the ground? But couldn't you also be -1, -2, -3 feet below sea level, right? So don't think that negative position is unrealistic. It does have a meaning and it can be done. Now, if you want to find the velocity at any given time, we know how to do that. We'll call the velocity function v of t. And don't you get that by just differentiating the position function? Simple as that. So in this case, it's a power rule. So 3t squared, take away 18t plus 24. Which means I can now tell you what the velocity of a moving object is. So for instance, let's answer the question A. If I wanted to know what is the velocity at the 1 second mark, the answer would simply just be plug and chug. 27 take away 18, I believe the answer is +9. And the units here are feet and seconds. So its velocity would be 9 feet per second. So in this version here, you would be traveling this way to the right at 9 feet per second. If the velocity was -9, wouldn't you just be traveling leftwards? So if it was vertical, up would be a positive, coming down the way would be negative. Now, not only can you use the velocity to tell you what velocity you're going at any given time, you can also answer questions like when. So I could say to you, when is this moving object at rest? Now that means the velocity is 0. Right? Well, if you're at rest, it's just a fancy way of saying your velocity is 0, right? You're not moving. Now, to find when, you're being asked to find the t value where that happens. So in this particular one, you write down the velocity and you set it equal to 0 and you solve. So you're going to be doing a fair amount of solving quadratic and linear equations. So anybody want to tell me what might be a good idea just to make this equation a little bit easier to do? Can you see anything that I might be able to do first?
Factor 3.
And if you factor out a 3, get this. And hopefully we're not too rusty about factoring. Since this is a t squared, there's 2 t's. You're looking for 2 numbers that multiply together, give you positive 8, but when you combine them, you get negative 6. So that's only going to happen if they're both negative. And you go through various combinations, but the one that, and the only one of the combinations that work is that, which means we have 2 different points in time when this object is stationary. Right, so you imagine you go out your house and you walk this way and then you think, oh, wait a minute, I forgot my keys. So you turn around and you go back again. As you're turning from right to left, isn't there a point in time where you're stationary, right, where you're not moving? Right? It's a bit like, you know, imagine going up and then you come down. Isn't there a point right at the top where you're stationary? So this happens in this story at the 2 and the 4 second mark. Now, the next question they're going to ask you, getting the letters down here, is D, is when is it moving in a positive direction? And we're to give our answer in interval notation. Now, when the velocity is greater than 0, right, when it's positive, you are moving in a positive direction. So in my story, you're moving that way. When the velocity is a negative number, not surprisingly, we say that you're moving in a negative direction, right? Which means you're moving that way, right? So positive, you're moving that way. Negative, you're moving that way. So we need to know for what values of t this is true. So the way you do that, although there are different ways to do it, this is the way I do it, is you create a number line. And on this number line, you're going to put the velocity. Now, you're not going to put the number, you're only going to put if it's a positive or if it's negative. Now, the 2 places where it's stationary are important. So let's put 0 here. There's -1, there's -2, there's 1, there's 2, there's 3, there's 4, there's 5. So you put a number line that at least includes these 2, and you put a little dot there at the 2 second mark, and you put 0 to remind yourself that the velocity is 0 here, and then you take another one and you go 0 here, and you make sure that you put a 0 in there as well. And what you then do to finish this table of signs is you choose test points. So that means you choose values of t in each of these 3 regions. So you can imagine there's a little invisible dotted line. So my test points are going to be at 0, at 3, and finally at 5. Now, I could have chosen 6, 7, 8, or I could have chosen 1, -1, or -2. I think 3 is pretty obvious. I don't want to make life hard for myself. Now, each one of these test points, we find the velocity and you can do the velocity in 2 major ways. I already have the velocity function here, right? One of the ways is, couldn't I just plug and chug? Couldn't I put t equals 0, get the answer, t equals 3 gets the answer, right? And t equals 5 get the answer, and that works. But when you get the answer, I don't want you to write 52 if the answer is positive 52. And I don't want you to write negative 12 if the answer is negative 12. All you write down is if the answer is positive or negative. So the first method is plug and chug. So for instance, velocity is 0, that's plus 24, but all I write down is plus. Now the velocity at 3, I'd put in 3, calculate and get the answer. If I wanted 5, I'd put in 5 and get the answer. There is another way, as I said. You can use this function here, right? The factored version of it. For instance, when t equals 3, won't 3 take away 2 be 1? And won't 3 take away 4 be negative 1? So won't that be positive, negative, positive? The whole thing is negative. When t is 5, that's positive. 3 take away, that's positive. 1, that's positive. Everybody is positive. Do you get what I'm saying? Because I'm doing this in my head. I'm basically just using the factored version of the velocity function. I'm plugging in the number here and here, and I'm just figuring out if this bit is a positive or a negative, and then plus times minus times plus combinations tell me that. Now, regardless of how you figure out these answers, you then go to your test point, you put a plus, and then you put a negative, and then you put a plus. And then the logic says this. Since this guy is positive, everybody is positive. And you might think, well, how can you make that assumption? Couldn't it be negative again? Well, if a positive thing turns into a negative thing, and it's done smoothly, doesn't it have to be 0, at least at one point? Right, to transition from an above to a below, right? From a plus to a minus, don't you have to be 0? And don't we know that these are the only 2 places that this can be 0, right? There aren't any more. So that's the argument. And that makes all these guys negative, and then it makes all these guys positive. So if you want to know when is it moving in a positive direction, isn't it moving in a positive direction for any values of t from 2 going that way, and from any value of t from 4 going that way? So the object is moving in a positive direction for values of t from negative infinity to 2. And I forgot to put a curve there. And from 4 to infinity. Are we comfortable with that? That's how you're going to figure out, is it positive, is it negative? Now, why is that the answer for WebAssay? And for probably most people and common sense. Why am I starting at 0 and not traveling all the way to negative infinity? Because I could actually. And in some questions I would. But why in this one am I starting at 0? Any suggestions? So it's not to do with maths, it's to do with common sense.
You're dealing with time?
Yeah. Unless you're into Doctor Who and traveling back in time, would you agree negative time is a slightly dangerous concept? That's the only reason. There are situations where that makes perfect sense. Can you imagine that we saw an asteroid out in space, right? And then we found out where it was given, at one you know, the 1 minute mark. We found out where it was at the 2 minute mark. And we created a formula that described its position, right? In that case, wouldn't -1 just mean where the asteroid was 1 minute before I saw it? Right. So in some circumstances, negative time is acceptable. But in WebAssign, it's being more realistic, I guess, and only positive numbers. Let's put this one in, even although it wasn't asked for. Well, if this is positive direction, and that's because the velocity is positive, and this is positive direction for the same argument, then won't this guy, because the derivative is negative, will be when it has a negative direction. And the interval is from 2 to 4. Now, this is interval notation. It doesn't mean the point 2, 4. It means all the values of time from 2 to 4. Why is it curved? Well, we are only interested when things are positive and when they are negative. We are not interested when they're 0. Isn't the velocity 0 at 2 and 4? So you don't count them. That's why. So if you're given a question about positive and negative directions, you typically would have curved. Of course, there's going to be an exception. And do you notice at 0, it's square? Because at the 0 mark isn't a positive number. Right? So it's just little things like that can catch you. Can you imagine you put the answer in with the right numbers, but you put a curve there instead of a square bracket? WebAssign is going to say you are wrong. Right, moving on then. We've just found a few minutes ago the velocity. Here's an easy question for you. How do you get the acceleration of this moving object at given time t?
The derivative of velocity.
Yeah. Nice and simple, right? As long as it's a polynomial, at least. You got that guy? Which I believe is the beginning of f. And then they might ask you, what's acceleration at time 1? In this case, the answer happens to be -12. If you're into the units, it's feet per second squared. And then it asks you to graph it, which is what Desmos is for. Now, right at the end, they have a very, it doesn't look like it's a big deal. The last question basically just says when, so we're talking about time again, is the object speeding up? And they also want to know when is the object slowing down. You might think that speeding up is a positive velocity and slowing down is a negative velocity. So you are just going to say, well, all I need to do is write these answers down again. But that's not the case. Speeding up and slowing down is a little bit trickier than that. I'm going to do something here. That lighting seems a bit weird. Is it kind of extra bright in the middle, or is it just me? Is that okay? Maybe it's just me. Okay. So, sorry for distracting you. I distract myself. An object is speeding up, right? When the velocity and the acceleration are the same sign. That means when they are both positive or when they are both negative, it's speeding up. And it's slowing down then. If you hear a lot of noise in the background, I apologize. We're getting a new roof. And my dogs don't like people on the roof. Hey, shush. Are you happy with me just giving you that as magic, or would you want to see a little bit of proof of why a thing is speeding up when both velocity and acceleration are the same thing, right? When they're both positive and they're both negative. Okay, I know. They're a little bit agitated. Come on, guys. Go to bed. Right, do you want me to go over that, or will you just treat it as correct? What do you want me to do? If you can hear me over the barks, I'm willing to let it go. I'm willing to show. I don't mind. What do you want me to do?
Can you show it?
Okay. Come on, guys. Move out the way. They're frightened, so they're kind of hanging around me. This is going to be a very interesting week, everyone. I'm going to have poor little dogs. Okay. I'm going to do a slightly different orientation. Right, up and down. Okay. So let's think of up and down and talk about speeding up and slowing down. So let's have a positive velocity, 5, and let's have a positive acceleration, 2. And let's just look at what is happening to this moving object when that is happening. So you start off with a velocity of 5. Now the acceleration of 2 tells you how velocity is going to change through time. And an acceleration of 2 means that after a second, the velocity will become 7, and then another second it's 9, and then another second it's 11, another second is 13. So can you imagine this object moving upwards, right? Or moving at 5 meters, 7 meters, 9 meters, 11 meters, 13 meters per second. Does that look to you like things are getting faster, right? Speeding up. Right. Now, let's suppose the velocity was -10, and let's say the acceleration was -3. So you start off with a velocity of -10. The acceleration means that the velocity after a second will be -13. Then it's -16. Then it's -19. Can you see that that object is heading towards the ground, but getting faster and faster and faster? Isn't -19 heading towards the ground more quickly than -10 is? So both the same, speeding up. Both the same, speeding up. Suppose you had a velocity of 12 and an acceleration of -2. Well, let's look what the journey would look like here, right? You start off at 12 and then you take away 2, then you take away 2, and then you take away 2. Would you agree that thing is slowing down? Now, suppose you had a negative velocity, like -15, but a positive acceleration, say 3. Well, the velocity would start at -15, then you'd add 3 to that number, and you get -12, then -9, and then -6. Do you see that that object is going downwards, but isn't it going downwards at a slower and slower rate? Heading towards the ground at 15 meters a second, now at 12, now at 9. And at least for a short part of its life, isn't that slowing down? And that would be the evidence. Now, the hard part of that is answering the question. So I'm going to take some information that we already know and show you how you put it together. We know the velocity. It was 3t squared 18t plus 24. And I'm also going to write down what its factored version looks like. And we also know the acceleration. And the acceleration is this guy. And I'm going to pull out a common factor of 6 and do that. Now, do you see this guy here? We're going to do him again. So I've got my velocity. I'm going to start at 0 because that's what Weber Science decided to do. And so it's going to start at 0 and go 1, 2, 3, 4, 5, 6. It's time. Now I'm going to do acceleration. And it's going to go 0, 1, 2, 3, 4, 5, and 6. Now the top one, I'm just duplicating the information. So it's 0 here, and it's 0 here. Then all these guys are positive. Then it changes over to being negative. Then all these guys are positive. And I'm going to do the same table, but with acceleration. What value of t will the acceleration be 0? Here's its factored version. For what value of t will the acceleration be 0?
At 3?
At 3. Are you all comfortable about what makes that 0? T equals 3 makes that 0. Now, I'm doing this in my head for speed as well. All I'm going to do now is find out what the acceleration looks like over here and what the acceleration looks like over here. So I'm going to pick a number 4 as my test point. You plug it in there, the answer is positive. So that makes everybody here positive. And you plug in 2 and it's negative, and everybody here is negative. So if you want to answer a question, when is something speeding up and when is it slowing down, you will begin by creating these 2 lines, right? The velocity one, and then really the same way, but with acceleration. And then you put the package together. And I'm going to add in some invisible brick walls. Have you noticed that I only put straight lines through the zeros, either the zeros when the velocity happens or the zeros when the acceleration happens. Now that has broken this region into 1, 2, 3, 4 regions. I'll call them region A, region B, region C, and finally region D. Now let's see what's going on in each of these regions. In region 1, right, from here to here, right, from 0 to 2 seconds, isn't the velocity positive and the acceleration negative? Speeding up or slowing down in that interval?
Slowing.
Slowing. Yeah. If it's one of each, it's slowing down. Okay, what about region B? From the 2 second mark to the 3 second mark, isn't the velocity negative and the acceleration is negative? Speeding up or slowing down now? What's happening in region B?
Speeding up.
Yeah, if they're both the same, speeding up. What about region C then? Let's be a bit quicker. Speeding up or slowing down? Region C.
Slowing down.
Okay. And lastly, region D. Speeding up or slowing down?
Speeding up.
Can you see, although that diagram is kind of messy to do, doesn't it tell you what you need to know? Because if you tried it any other way, I'm not quite sure how successful it would be. So it does involve a bit of work, but now I know everything I need to know. So the question went and said, when is it speeding up, right? Well, it's speeding up in two intervals. It's speeding up from during the 2 to 3 second mark, and then from 4 forever. And when is it slowing down? Well, it's slowing down from 0, guess I should put a square bracket on that, 0 to 2, and where's the other one? From 3 to 4. It's a long question, wasn't it? What that tells me is that I know pretty much everything you could possibly want to know about that moving object, when the only thing that I started with was its position function. And that's just power of calculus. If all you know is where something is at any given time, don't you also know its velocity at any given time, its acceleration at any given time, when it had stopped, when it was speeding up, when is it slowing down, right? All sorts of things. We also can tell you how far it has traveled. And so let's look at how you do that. Oh, which one is the distance traveled? E. Okay. Remember the velocity guy, right? This guy here. This guy here. You can use him to find out what the distance is traveled. So let's suppose I'm interested in the distance traveled in the first 6 seconds. You might think, well, all you need to do is find out where it is at the end of 6 seconds, take away where it started from, and that will be your distance traveled. You would think that. It's not, unfortunately, the case. If it was, it'd be a dead easy question. And you might say, but why isn't that the answer? Right, that's where it is in 6 seconds. That's where it started. If you take one away from the other, surely that's the distance traveled. Well, it's not as simple as that. Moving objects don't do what you want them to do. I want you to imagine this is the position of the object, right? Let's say you have this guy here, right? So he starts off here, but you could start anywhere. Couldn't you go there, come back, go there, and finish here? And you're 5 feet away from your home. Right, so that's where you are at S6, right? And that's where you are at S0. But did you travel 5 feet? No, didn't you travel all the way to there and turn around and come all the way back and then turn around and went all the way there and then turn around and almost came back home but never quite made it? Can you see that there's a lot more distance traveled than just the difference between where you started and where you finished? That's why this does not work. So what you have to do is you have to go and you have to look at the velocity guy. So in this velocity guy, there's a 0 to 2, and then you go from 2 to 3, and then you go from 3 to 4, and since I'm only interested in 6, you go from 4 to 6. So I'm actually breaking his journey into 4 separate bits. I'm basically trying to find that bit, then that bit, then that bit, and then that bit. And so I'm going to get the answers to each of them, and then you add them up. So the position at the 2 second mark, take away the position at the 0 mark. You never thought this one question was going to be today's work, did you? Well, let's see what's happened. At position 0, well, let's do position 2. 2, 4, 8. God, this is too hard to do in my head. That's what calculators are for. Although, right. At position 2, it's 20 feet away. Take away 0, so there's 20 feet. So that journey took 20 feet. If you want to know how far you travel from the 2 to the 3 second mark, at the 3 second mark, was it 3 or 4? My apologies. Two to 4. It only had 3 journeys, 0 to 2, 2 to 4, 4 to 6. Right, so position at 4, take away position at 2, and this guy is 16, this guy is 20. I know that number is -4, but we are only interested in distance. So you traveled 4 feet, right? So think of absolute value. Now from 46, the position at 6, take away the position at 4, and the position at 6 was 36, and the position at 4 was 16. So that would be another 20 feet. So the total distance is 20 plus 4 plus 20, which in this case is 44 feet. So let me explain a little bit more clearly what I did there. Hide that one because it's distracting me. Find the interval where it was positive. Find the interval when the velocity is negative. Find the interval when it's positive. That's 3 separate intervals. For each of these intervals, find the position at the beginning, at the end, and subtract them. Beginning and the end, subtract them. Beginning and the end, and subtract them. Don't care if the answer is positive or negative, make them all positive, right? Because it's a distance. We're not interested in direction anymore. So that was 20 feet of movement. That says -4, but that counts as 4 feet of movement. And that's another 20. Add them together, you're done. Any questions about that, whatever it was, 5-page question? Can we move on? Right. Hopefully you'll have caught most of that. Now you can do a lot of the same kinds of things with different position functions. So I'm not going to go through that entire list because it takes too long. But let's give you a little taster of some of the things. Suppose your position function is given by the sine of pi t over 2. You want the velocity? You can differentiate that. That we should be good at. Well, yeah, we should be good at it, but there's so many techniques that you've learned that sometimes you have to think a little bit about how I'm going to do this one. I don't know if this helps any, but it helps my brain. Do you know that guy is this guy? Just a different way of writing it. So this is a chain rule, isn't it? So when I differentiate the sine of pi upon 2t, I will get the cosine of pi upon 2t times the derivative of the inside function. And what is the derivative of pi upon 2t?
Pi over 2?
Yeah. I don't know why, but when I see that, it's harder for my brain to understand. It's just easier when I see this. It's just me. I guess if you wanted to do style points, which I really should, I'd do that. Are we good? Right, now if you want to find the velocity at 2 seconds or 22 seconds, couldn't you just plug in the number? Now let's do one of those. When is it at rest? See if anyone can remember. What is the value of the velocity when an object is at rest?
When velocity is equal to 0.
Okay, so we are now going to have to solve a rather weird, awkward trig function. Now that pi upon 2 doesn't matter, so I can divide both sides by pi upon 2, and we are only looking at solving that, right? Now in 142, we solved some trig equations, and this one is one of them. In this particular question, there is an infinite number of answers, and it says use the parameter n as necessary. In that I would use k, but they want n, that's fine. Okay, unit circle. Can anybody tell me when is the cosine equal to 0 on a unit circle in radians?
Pi over 2 and 3 pi over 2.
Right. Okay. Would you agree pi upon 2? Would that be one of the answers? Now, is there other answers? Agreed. Oh, doesn't that make t equals 1? Okay, what other answers could there be? Because a unit circle has at least got 2 answers. What would the other one be? We've got vertically upwards. What's the other value where the cosine is 0? I don't want to tell you.
3 pi over 2.
4.
Okay, 3 pi over 2, which tells you that t equals 3. Now, what is the period? Yep, 142 stuff. What is the period of this guy? Two pi divided by this guy. Right. Agreed? Okay, let's try a different way then. If I did the next one, the answer would be t equals 5. If I did the next solution, it would be t equals 7. If I added the period on, the next one would be 9. If I added the period on, it would be 11. Can anybody see a pattern in all these different values of t? Do you see they're all odd numbers? You notice that? And so that's what they were after. That as long as t is 2n plus 1, where n is any number, 0, 1, 2, 3, 4, you could also do, I don't see why you shouldn't be able to do, you could also do that one, but then you'd have to make sure you started at 1. Okay, talk through the rest of this because we don't have a lot of time. If I want to find the acceleration, don't I just differentiate this guy? If I wanted to find acceleration at the value of 1, well, after I differentiated it, I would put t equals 1. A lot of the questions ask you to draw graphs, but isn't that what Desmos is for? And then the last piece of the puzzle is that you're going to do, again, Desmos wants you to start at 0, so that's fine. You're going to do one of these velocity acceleration things. And we only need to go, where do we need to go? Well, that is interesting because they are wrong. Unless there's a restriction I can't see. Ah, okay. If you it does go on forever. But if you do the velocity, you will find out that it's 0 at 1, at 3, and 5, and 7, and 9. And if you do the acceleration, it's 0 here, 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 and here, and it goes on forever. Okay. Now, if you do pluses and minuses, again, you're just going to have to trust me. There are lots and lots of regions here. Actually, they go on forever, but for some reason they stop at 6, so I'm stopping at 6. And what you're going to get then is that it's speeding up here, and it's down here. Then it's speeding up here, and then it's down here. And it's up here, it's down here. And that's it, we're finishing that one. And if you just plug in, let's plug in somebody. Let's plug in 0. So if I plug in 0 for the velocity, I get a positive answer. Then I get a negative answer. Then I get a positive answer. Then I get a negative answer. And if you do the acceleration one, you get that. And so they're the same, they're different. Oops. They're the same. They're different. They're the same. They're different. Okay, so I got my pluses and minuses. Working on the answer. So those two examples are all we have time for today.